So today we're going to be learning about heat transfer. Do you have any idea what heat transfer might be? No idea.
No idea.
What do you think it might involve?
Transfer of heat, maybe from one object to another.
Okay, that's good. So we have transfer from heat, potentially from one object to another. Do they have to be in contact? Or are they just going to be apart from each other?
Maybe both.
Okay, so from this object to that object apart, might be in contact. That's great. And then another thing is also throughout an object. So if you've ever placed like a fork on a stove, I haven't done that, but if you did, you would have one end of the fork heating up and then the end of the fork would eventually get hot as well. Maybe the same thing when you put a saucepan on top of a stove and then the pot end of the handle starts getting warm as well. So that's great. Few different things of transfer of heat that we will get to eventually once we cover the theory, but for the moment we're going to look at a demonstration. There's a little bit of wind, so we might not fully see a cup burn because that's what we're going to demonstrate to start with. So I kind of just gave the answer away, but what do you think will happen if a cup is placed above?
It would eventually catch fire.
Okay, eventually catch fire, sweet, but it starts off with just burning to start with. Okay, so that might be the only part we see today. So let's maybe even leave the match there. So we are seeing it burn. And eventually we'll probably see it catch fire. Yeah, there we go. So the cup is now caught fire. Luckily I have some water prepared. So you just put it straight in the water and it's all good to go. So your hypothesis was correct. Let's leave the candle going. Now, we use water to put it out. What could we do to this cup to stop it from burning in the first place?
Put water in it?
Put water in the cup. Yes, that is a great theory. Why do you think putting water in the cup would be helpful?
Because it's an extinguisher.
An extinguisher, okay. In what sense?
Well, you put water on fire to put it out.
Cool. So you put water on fire to put it out. What about on an oil fire though?
Don't know.
Okay, so if you were to put water on an oil fire, it's not necessarily going to extinguish it, so it's not necessarily that that's putting out the flames. But I think it's a great idea to start with for this, and afterwards we'll see what happens. So let's just put a small amount of water in to start with. You don't need a large amount. And we've still got that candle burning. Let's just light up a match just to see if that will help us burn here. So I'm going to get down. Is there anything happening above the cup?
No.
Okay. Underneath though, before it went out, just because I think of the wind, it was starting to burn, but there's no burn on the top. So why do you think that's the case?
Not sure.
Not sure. Okay. So with heat transfer, you talked about how heat would go from one object to another, or how it could go throughout an object. And when it goes from one object to another, they might be touching, they might not be touching. So what's happening here is when we put the cup above it to start with, we had a flame, and let's actually put the candle back on for a second. I said put it back on, but it doesn't really get put back on. Now, do you need to be touching the candle to feel the heat? Can you put your hand just near there? So you can feel the heat, right? Awesome. If you couldn't, there'd probably be a problem with physics. So you can feel it by having your hand around it. Another thing is when something's warm, you can just touch it and feel the warmth through it. And then lastly, heat moving through something. So you might have like your feet by a heater, and heat your feet up, and slowly your whole body might end up warming up as well. So what's happening when we put this above, it is traveling, but kind of from one object to another. So the source, which is the flame, it's not in contact, but it's radiating heat. So that was one form. From one object to another, where they're not in contact, this will radiate heat to another, which is what we were demonstrating there. But when you start putting water in it, the heat that was radiated from the flame is coming in contact, and as we saw, was it this cup? Yeah, it was burning the bottom. I'm not sure. Let's see if you can see. It is burning the bottom, but wasn't burning through the top. Now, what is happening there is the heat is kind of dissipating into the water. So rather than the heat transferring throughout all the paper, and everything has a melting point, like ice, it melts at 0 degrees. Paper, for another thing, also has a melting point, or it'll start melting and just turn into a flame essentially. But what the water's doing is it's taking that heat, so the heat is transferred into the water. So if we left it there long enough, the water would eventually heat up, but our candle's going out before then, so we can't really demonstrate that. But just like that, you're putting it in, and if this was maybe a Bunsen burner, we had access to one right now, we'd probably be able to demonstrate that the heat coming out of that is too intense for the heat to then transfer to the water before it starts burning. It would probably burn before the Bunsen burner, before the heat can get transferred to the water. So, to recap, kind of what we've just observed in this demonstration, what did we do to start with?
We just burn a cup.
Burn a cup. Okay, yeah, super simple. And why did the cup burn?
Because it didn't have anything to extinguish it. It was transferring heat from one object to another.
Yep, and then the heat within the cup, what was it doing? It was just burning up.
Burning up, yeah.
Because it didn't transfer to anything.
Yeah.
So it just relied on itself. But the moment we've stuck some water in it, once there is water in the cup and the heat is being transferred to the cup.
To the water.
Yeah, it's going not just to the cup, it's actually going to the water now. And that means that the heat isn't actually able to burn because the heat is transferring to the cold water.
Yeah.
And that's one of the last things I want to mention with heat transfer. It's never going to go from a cold object to a hot object. It's always going to go from hot to cold. So if we put in really hot water, if, let's just say the melting point of this was really high, and you put hot water in, well, the hot water wouldn't melt the cup, but the heat would start going to the cup from the hot water. But because we've got cold water in, the heat is going to be going into the cold water.
So it would eventually, like, if we left it there long enough and the flame didn't go out, would it eventually turn to steam?
Yeah,
It got hot enough?
eventually.
So it'd start evaporating, and that's when the cup would catch on fire.
Yeah, well, it depends. If the melting point of the cup, so water starts kind of turning into steam, can't remember. I know at boiling point it's 100 degrees Celsius. So let's just assume the steam's going to start forming at 100 degrees Celsius. If the melting point of the cup is below that, the water, let's just say it's 60 degrees. The water will get to 60 degrees, but because that's the melting point of the cup will then start melting because any more heat, even if it goes to the water would then start melting the cup as well because it's hotter than the melting point. But if the melting point of the paper cup is higher than 100 degrees, we would start seeing the steam first, and then the water would just start evaporating until there's no water left, and then the cup would start burning. But unfortunately we can't demonstrate that here because we don't have a Bunsen burner or a system to be able to hold the cup up long enough. But yeah, as we can observe, it is actually burning the cup underneath. But yeah, that is essentially the basics of heat transfer. And just to let you know the actual names, radiation, you might have heard of radiation before. It's like X-ray, that's a form of radiation, you're not touching it. So that's actually going from one object to another. So that's radiating heat right now. If we were to touch something hot, or have something hot like a metal, like a saucepan, and it's heating at the stove but the handle's still hot, that's conduction. So it's actually moving through the object. Or if you're in contact with it and then it's going to you, that's conduction as well. But then there's something else called convection, and that is kind of the movement of liquids and particles. So when you see boiling water, all the bubbles, it creates circulation. Like the top doesn't just steam and slowly steam off. The water is circulating because the bottom of the water is getting hot. And then the hot water rises, just like hot air rises. The hot water will rise, and then that turns to steam, and that can maybe become a bubble because the water turns to steam at the bottom, and it's trapped underneath the water, so it has to rise, and poof, out it comes. And then everything on the surface might get cold, and it might start to circulate underneath, so that's convection. So there are 3 types of heat transfer. What were they?
Radiation,
Yep.
convection, and
Conduction. That's right. So this demo, we'll have a safe system set up for you to be able to go and demonstrate or work with in a second. But yeah, we'll get to our workbooks, put those down, and we'll have some theory up on the board. So thanks for watching the demo. Thanks for linking in, Crow. Catch you around.